Hello friends, welcome to MG Engineers Academy. In last session, we discussed the property of Laplace, which is derivative property of Laplace. And in today's session, we are going to discuss problems related to it. So, first problem, find Laplace of d by dt into sin t upon t. So, we have to find the Laplace for this term. Now, here, what formulas we are going to use here? Laplace of sin a t will be a upon a square plus a square. This formula we are going to utilize. Then we are also going to use one property, division property of Laplace. This is second, and third we are going to use derivative property of Laplace. So in this example, we are going to use these three simple steps to find the answer, right? So let's get started. First, I am going to find Laplace of sin t upon, sorry, sin t. I'm going to find the Laplace for sin t. Laplace of sin t. So what can I get as per this equation, which we have a upon a square plus a square, right? This is the formula which we have for sin 80. Now, what we are going to do, we have here term t, 1 into t, means value of a is 1 here. So, I'm going to make changes in the same equation. So, 1 upon a square plus 1 square will be 1. This is the Laplace of sin t. Now, by applying division rule. When I apply the division rule, I'm going to get the value of this term sin t upon t. So what can I write here? Gs to infinity f bar of es into ds. So es to infinity 1 upon s square plus 1 into ds. So we have some standard formula again. Tan uh, 1 upon integration of 1 upon x square plus a square into dx is equal to 1 upon a tan inverse x by a. This is a standard formula which we have. Similarly, we are going to apply the same logic here. So what can I get? 1 upon a is 1 tan inverse, right? Tan inverse x by a. X is here, s by a is 1 and limit s to infinity. What can I write here? Tan inverse yes, yes to infinity. Now I'm going to put this upper limit and lower limit. What can I write? Tan inverse infinity minus tan inverse of yes, right? Tan inverse value, tan inverse infinity value is pi by 2 minus tan inverse s. Now we have one more formula that tan inverse x plus cot inverse x is equal to pi by 2. So this is the same form, right? Just we have to make some arrangements here. Pi by 2 minus tan inverse of x. So pi by 2 minus, when I take tan inverse plus tan inverse x here, then it will be minus tan inverse of x is equal to cot inverse of x. Same logic I'm going to apply here. Pi by 2 minus tan inverse of s will be cot of inverse s, right? Cot inverse s. Now this is the value for Laplace sine t upon t, right? Now next step. Now we have to find the Laplace of d by dt, right? D by dt, right? This term, right? Means we have to find the derivative form. Now, simply, I'm going to apply the formula here. I'm mentioning here by applying derivative property of Laplace, right? So, what can I write here? Derivative property of Laplace. So, what is that property? Laplace f dash of t is equal to, yes, f bar of yes plus minus f of 0. Now, what we are going to do? First, we are going to find f of 0. Okay, so let me find out here. So, how can I find the value f of, so f of 0 will be f of t is equal to f of 0. Then, what is the f of t? We are going to utilize this same sin t by t as the f of t value. Means I'm going to apply sin t upon t at t equals to 0, right? Now, when you put the value of t is 0, then what can I find here? 0 upon 0. So 0 upon 0 is infinity. So we are not going to use the term infinity because it's a meaningless. So in order to get the value of f of 0, what we are going to do? We are going to take limiting value of f of 0, limiting value, limit t tends to 0, sin t upon t. And we have one standard formula for this limit, limit x tends to 0, then sin x upon x will be 1. This is the standard value which we have. So sin t upon t will be 1. So f of 0 will be 1. Right? We have found f of 0 now. We have reached f of 0. Then we are going to apply the same logic d by dt sin t upon t is equal to, yes, f bar of s is cot inverse of s minus f of 0 value will be 1. So this is the answer, right? This we have to find out. So now, now we are moving to next example. I am going to mention find Laplace of t by dt 1 minus cos t upon t, right? So we are going to use the same logic and same formulas in this example. So first, what can I do here? First, I'm going to find the Laplace for this term. Laplace 1 minus cos of t. How can I get Laplace of 1 minus Laplace of cos of t? So we have one formula, Laplace of cos of t. Laplace cos t will be s upon s square plus s square. So same logic here. Laplace of 1 will be 1 upon s upon cos of t s upon s square plus a is 1. So I have received the value for 1 minus cos of t is 1 upon s upon into, sorry, 1 upon s minus s square plus 1, right? Now I'm going to find the value for cos of t upon t in Laplace form. How can I find the value for this? So I'm going to apply one rule here. I'm going to apply rule of division. Means by applying division rule. What can I write here? Integration s to infinity. A bar is 1 upon s minus s upon s square plus 1 into ds. So in order to balance the term, I'm going to multiply and divide by 2 here, right? So what can I get? 2 by 2 into 1 upon s minus 2s upon s square plus 1 into 1 by 2 into ds. Why I have made these changes here? In order to get that, in last session, uh, think in property of division example, we discussed that we have one formula for 2s means integration of f dash of x upon f of x will be written as log of f of x. So I'm going to apply the same logic here. Now I'm going to take 1 by 2 common s to infinity 2 upon s minus s to infinity 2s upon s square plus 1 ds. Now what can I write here? I will take 1 by 2 outside s to infinity 2 upon s minus 2s upon s square plus 1 into ds, right? So what can I get here? Now if I integrate this term, then what can I write? 1 by 2 2 log of s minus, at this place I can write log of s square plus 1 and limit s to infinity. How I got this? We have one standard formula here. integration of 2x upon x square plus 1, or we can say f dash of x upon f of x. We can write log of f of x. So how I can get, if I took this example, 2x upon x plus 1. If you differentiate this term x square plus 1, what can I get here? 2x, right? And means I am getting at the 2x at the place of f dash of x. So 2x upon x square plus 1. So I can write directly f log of f of x. That is logic where I have applied here. So 1 by 2 log of s square minus log of s square plus 1, limit s to infinity, 1 by 2. Here x log of y is equal to log y raised to x. This logic I have applied here. Now I am going to use another formula of log a minus log b is equal to log a by b. So log of s square upon s square plus 1 s to infinity. If I put the limit value here, log of infinity square upon infinity square plus 1 means anything infinity will be infinity, and this infinity upon this infinity will be 1. Log of 1 will be 0 minus log of s square upon s square plus 1. Simple. Now I am going to write it as 1 by 2 minus log s square upon s square plus 1. I can write here s square plus 1 upon s square directly. Alright. For further simplification, we can also write log of s square plus 1 upon s square raised to 1 by 2. For further simplification, I am also writing this way log of s square plus 1 upon s square. After further simplifying, I can write it as log of s square plus 1 upon this s square and this root will be gone. I can get yes, right? Till this, we have find the value of Laplace of 1 minus cos t upon t. Now, we have to find d by dt of Laplace of d by dt of 1 minus cos t upon t, right? So, in order to get that, I'm applying one more logic here. I will mention by applying the derivative property. And what can I write here? I can write yes into a bar of s means log of x under root s square plus 1 upon s minus f of 0. Now, what is the required? We have to find the value for f of 0. And how we are going to get that? So in order to get that, I'm going to make here another row. Okay, so f of t is equal to f of 0 is equal to 1 minus cos of t upon t at t is equal to 0. If you put value of t at 0, you will get 1 minus cos of 0 1 t t0 0 1 minus 1 0 you will get again 0 upon 0, so it's a meaningless and it's an infinity term, so we are not going to use that. In order to get the value of f of 0 we are going to apply limiting value of t. So limiting value, what can I write here? Limit t tends to 0 1 minus cos of t into t. So we have a standard formula. Limit x tends to 0. 1 minus cos x upon x will be 0. Same logic we are going to apply here. So I am going to get value of f of 0 will be 0. So I am going to put yes log of x square plus 1 upon yes a minus f of 0 will be 0. Hence log of s into log of s square plus 1 upon s will be the answer for this derivative of Laplace derivative of d by dt 1 minus cos t upon t, right? Okay. Uh, if you have any doubts or any need any clarification on any example, please comment me.